right now. Okay, it's doing good. Delete. Okay, guys. I'm gonna try. This is 44%, and this has how much on it? 48. Can we use that? Okay, guys. There's this thing I'm gonna watch real quick online. It tells you how far long it takes to get to the planets from the source. How long it takes to get to each planet. So we're gonna watch this real quick, and then that's about all I'm gonna say. That's all we're gonna be watching right now. How long it would take to get to each planet, which we know it takes about 3 days, 3 to 4 days to get to the moon. And the moon days are easy to get to because the moon's closer to us. The moon's like what 400,000 miles. It's my nose. The moon's like 400 miles from here, like 400,000 miles from us. So it's pretty easy to get to the moon. You don't know about that. So we're gonna wait. I don't even know why I'm using this charger for. This charger doesn't have one because this phone is too weak to charge my phone up. I use the big charger for using the charger connect and D-tape because the D-tape charger works better than that charger did. I use the charger wrapped in duct tape because of the phone. Hold that charge up for a little bit. So, okay, guys. So here we go, guys. How far are you from each planet? We know the moon's like 500,000 kilometers from here, or 400,000 kilometers. So let's start, shall we? Because this came out back in May. This came out like last month, so we're gonna watch it. I'm gonna turn it up so you guys can hear
We'll
it.
start from the planet closest to the sun to the farthest, starting with the smallest planet,
Mercury.
This planet revolves around the sun in an orbit that varies from 46 and 70 million kilometers between the closest and farthest point, respectively. Remember that the orbit of the planets around the sun is not circular, but rather elliptical, which means that there are times when the planets are closer to the sun and other times when they are farther away. The point in the trajectory around the sun of a planet where it is closest to the sun is known as perihelion, and the point at which it is farthest away is known as aphelion. You should also consider that planets move at different speeds around the sun, and the farther...
Like for example, Michigan. Okay. Now I do remember reading something about like right now where the further. I do remember reading something online, guys, that this is true. We're closer to the planet. If you, well, not if you're we're closer to the sun in January, and we're further from the sun in July. Like right now it's summertime here in July. Like right now it's July here in the U.S. It's summertime. It's July. We're actually further from the sun in July than we are in June. In July we're further from the sun, but in January, December, January, we're the closest to the sun. In January and December, we're closer to the sun. In December and January, we're a lot closer to the sun, which is our winter time here in the United States. So is that pretty neat? I know it's not really true. It's kind of odd, but it's true. We're actually closer to the sun during the winter months, during the Christmas time, and then during the summertime, we're far, far away from we're the furthest point from the sun is in July.
The way they are, the slower they move.
That's all I'm going to say.
The farther
And
away
Venus is upside
from
down.
the sun, the longer its years last, since it takes longer to complete an orbit. When Mercury and Earth are on the same orbital side around the sun, that is, the sun is not in the middle of the two, the distance between the two is 77 million kilometers. If we want to travel to this planet, we will have to do it at this time, when both are on the same side of the sun. Because if we do it when the planet is on the other side of the sun, the distance that would have to be traveled would be more than double. What method would we use to reach each planet? Although in our daily lives we're used to getting from point A to point B through straight trajectories, in space it does not work since the planets are constantly in motion. If we get on a spaceship and start the journey to a planet in a straight line, when we finish reaching the end of that line, the destination planet will no longer be there, because during the entire journey the planet moved and changed places. To move in space, it's necessary to do through curved lines and using some aerospace engineering maneuvers. But for this video, we will focus on one of those maneuvers known as Hohmann transfer.
Okay.
Hohmann transfer is an orbital maneuver in which it is
possible
to move a spacecraft from one orbit to another using impulse with motors. For
Okay.
this exercise, you should consider that the planets move at different speeds. In the case of Mercury, it moves around the sun at a speed of 169,200 kilometers per hour. or 105,136 miles per hour.
Thank
The
you.
fastest human crewed space mission in history belongs to the Apollo 10 spacecraft that in 1969 reached a speed of 24,791 miles per hour, or 39,897 kilometers per hour on its re-entry to Earth. Have you noticed it yet? The fastest human crewed spacecraft that has been built moves much slower than Mercury. That is, in order to land on that first planet, we would have to reach its speed by accelerating the ship for a long time or using the preferred propulsion method of astronauts.
My name's Eureka. I live here in Rocky Falls with my family and my friends Pepper and Barry. Boom.
Wearing sandals.
And every new invention leads to brand new adventures. Let's do it.
Why would you wear sandals for? I thought you'd be barefoot.
Watch New Eureka on Disney Junior.
Nope, it's not. It's not Disney Junior. But this is pretty interesting, guys. It's a couple years to get to. We know it takes about 7 months. It takes about 7 months to get to Mercury. I know, for example, it takes like 7 months to get to Mars. I know that for a fact. It takes 3 days to get to the moon. It takes 7 months, like 7 months to get to Mars. I know it for a fact.
Gravity assist. Gravitational assist is a maneuver intended to use the energy of a planet or
We could survive on Venus. Venus would kill us.
to obtain an acceleration or braking of a spacecraft by changing its trajectory.
Jeez.
And it is the favorite method of propulsion of astronauts since it does not require fuel. What is used to propel the ships is the gravitational field of the celestial bodies. This method is one of the most used to take space exploration probes very far in the solar system.
Oh,
This
okay.
is how it was possible to take the Voyager probes to the ends of the solar system and will surely be one of the methods used when we begin to travel through all of the planets. The only drawback with gravitational assistance is that it is a slow maneuver. For a ship to make the most of the gravitational influence,
It took about 30 years to get Voyager. Was it Voyager? Was it Voyager 1 or Voyager 2 that passed Pluto a few years ago? Because it took them 30. Because Voyager 2 took. I remember, was it Voyager 1 or Voyager 2 that went past Pluto a couple years ago? I forget. But either way, though, 30 years later, it left Pluto. 30 years ago. I mean, back in the days, we had Voyager 1 and Voyager 2, okay? Recently, Voyager 1 or Voyager 2 passed Pluto 30 years later. Still, after that, it left the solar system, but it's no longer getting used anymore. But still, they still have technology to still use it, which is pretty cool. Thing is, though, the Voyager uses 8-trap tapes. How many of those are left in the world? I mean, you can still get them, Bo, but they're pretty pricey to find.
of a celestial body, it must give a couple of orbits around it or have tiny impulses from different
I did
planets.
3 videos on 8-track tapes, my channel.
If we want to travel to the planets, we will have to get another means of impulse that is neither the chemical fuel nor the gravity assist.
Nuclear?
Fortunately, in a
Solar?
previous video, we talked about what those propulsion methods could be. Subscribe to the channel so that you do not miss all the videos related to space travel. Since we've made clear the drawbacks that would arise in a hypothetical space trip, we enter the main point of the video. How long would it take to get from Earth to the planets of the solar system? Mercury. Following a plan in which we use a mixture of chemical fuels and gravitational assistance to reach the speed that Apollo 10 spacecraft reached in 1969, in the best possible scenario, and using the most modern spacecraft, we could reach the orbit of Mercury in about 7 months.
Okay,
Just
7
as
months?
You heard, 7 months to reach the
Just like
slowest
Mars.
planet of all. But don't get too excited. Remember that this planet is very close to the sun and has no atmosphere. Even if we reached that planet, we couldn't stay there for very long, since solar radiation would cause irreparable damage to our body.
Yeah.
Venus.
Nope.
The second closest
We're never getting on
planet to the
Venus.
sun is Venus, which is also the hottest planet of all.
And
How
dangerous.
is it possible that Venus is hotter than Mercury if Mercury is closer to the sun? This phenomenon is because Venus has a weighty atmosphere rich in CO2, while Mercury is a massive rock without an atmosphere. In Mercury, the surface
And Venus is
temperatures
backwards.
depend on whether the area is under the sun's rays or not. In this way, in the areas where it is daytime, the Mercury surface can reach temperatures of up to 467 degrees Celsius. In comparison, in the areas in the shade or at night, they can reach up to minus 183 degrees Celsius. Venus, on the other hand, is a planet with a structure similar to the Earth.
And it's upside
The
down
difference
too.
That it has a very different atmosphere.
Venus is upside down.
While on Earth there are clouds of water vapor, on Venus there are clouds of sulfur. At the same time on Earth it rains water, on Venus it rains sulfuric acid. And while on Earth there are rivers of water, on Venus there are rivers of lava. In addition, it has a very high seismic activity. There are tremors all the time, active volcanoes everywhere. Due to all these conditions, on Venus the temperature is constantly above 468 degrees Celsius. At these temperatures, metal begins to melt. That's precisely what happened to the Venera 9 and 10 probes, which
Russia.
landed on Venus in 1975. But minutes after landing, some of their instruments began to melt and fail due to high temperatures and crushing atmospheric pressure. Fortunately, they survived long enough to send us the only images we have of the surface of Venus. Returning to space travel, at their closest points, the Earth and Venus are 40 million kilometers away from each other, and a trip to that planet in our fastest spaceship would take us at least 5 months.
Okay,
Mars.
5 months.
Better known as
Mars.
the planet, Mars is the most famous planet after Earth. However, it is not the closest, since at its closest points, the distance between Mars and Earth is 59 million kilometers. But this is not always the
69K.
case. When Mars is on the other side of the Sun with respect to Earth, the distance between Earth and Mars is equivalent to the distance we would have to travel if we went from Earth to Venus twice. Every
Okay.
26 months, the orbit of Mars and the orbit of the Earth causes both planets to get closer than usual. This is what is known as the launch window, which is when space agencies take advantage to launch any spacecraft or probe they want to send to the red planet, since during this short period, Mars and Earth will be closer than ever. In this way, the ships launched in the launch window that occurs every 26 months will need much less fuel to reach the red planet than if they were launched at any other time. Taking advantage of the launch window between both planets with current technology, it would take approximately 10 months to get from Earth to Mars, and that's only for the one-way trip. For the trip back to Earth, astronauts would have to wait 26 months for Mars and the Earth to approach again. Jupiter. Jupiter, the gas giant, is the 5th closest planet to the Sun and is located at nothing more and nothing less than 640 million kilometers. This distance is more than 10 times greater than the distance it takes to get to Mars. In astronomical units, this would be equivalent to 4.2 astronomical units. Remember that an astronomical unit is an average distance from the Earth to the Sun, approximately 150 million kilometers. That is to say that the time it would take us to go to Jupiter only once, in that same time you can go and return from the Sun twice. With 2022's technology at the maximum speed possible, it would take about 3 years to reach the planet only for the upward journey. A round trip would take about 6 long years. Saturn, the Lord of the Rings. This planet is 1,275 million kilometers away. That is 8.5 astronomical units, the equivalent of going 8.5 times to the Sun or going twice to Jupiter. A spacecraft of the current era would take more than 4 years to reach Saturn. That is to say that a round trip would take 8 years. The astronauts probably should carry some puzzles or something to do while hanging out for those 8 years so they're not so dull. Uranus. Uranus is the next farthest planet after the Sun. It's located approximately 2,970,000,000 kilometers from Earth, at its closest point, equal to almost 20 astronomical units. 20! In fact, if you have paid attention so far, as we move away from the Sun, the distances between the planets multiply exponentially due to the decrease in gravitational attraction. Current spacecraft would take about 10 years to reach the planet. A
Okay.
decade to go to Uranus. That is 20 years for a round trip back and forth. Half of a human life. Neptune. Finally, Neptune, the coldest and farthest planet of all. This one is located 4,300,000,000 kilometers from Earth, which is equivalent to almost 30 astronomical units. 30. Going to Neptune is like going back and forth 15 times to the Sun. With the most advanced spacecraft of this era, it will take 20 to 25 years to reach Neptune. We haven't even left the solar system, and we're already talking about decades of travel. It's clear that the spacecraft of this era are not ready to undertake interplanetary travel. We need ships that can make those trips much faster so that we don't die along the way. For now, it seems that there is a long way to go before humanity begins to colonize other planets. We're only missing Pluto, but let's remember that Pluto isn't a planet. But if you'd like us to talk about how long it would take us to reach the dwarf planets of the solar system, such as Pluto, Ceres, or Makemake, let us know by liking this video.
Pluto's still a planet in my book.
Don't forget to subscribe to the channel so you don't miss any of our...
Pluto's still a planet. Pluto's still a planet. Pluto's still a planet. Even, yeah. Pluto's still a planet, guys. Pluto's a planet. Pluto still is a planet. Neebs Gaming menu stuff.